All right. So this is lesson 8 in the LRC Python class. Today we're going to go through line by line how to code a system check kind of program. So if in the last lesson you saw basically what the monkey has to do, or in this case you, is take the cursor, touch a start button, and then once the start button's hit, a button will appear in one of 4 places. And then you just need to go click that button and then you get rewarded with a pellet. So we're going to move through that line by line. And I'm just going to teach you how to do this, and you have access to the code. So feel free to use that code to build off of. It's completely open access. You guys can use it for whatever you'd like. And yeah, and we'll build off this in the future. This is a pretty simple program, but it's lays the foundation for almost every program you would possibly need to make. So yeah, by the end of this video, hopefully you'll have your own little system check program coded. We'll go ahead and get started. All right, so let's pull up, first of all, when you go to that GitHub on that previous page, you should have a folder that looks a lot like this, right? So it's got some folders. I usually have an old versions folder where you save old versions of the task. It's probably good to do that every once in a while and just date it just in case you start coding and you really screw something up. For example, if you accidentally indent something and you can't figure out what you did wrong, it can be a really tedious process, and sometimes it's easier just to go back to a previous version. So before I start working on any version of a task, especially if I'm going to make a major change, I go ahead and copy the old version and put it in there. There's a stimuli folder where you can store a lot of stimuli if you have hundreds and hundreds. For this one, we don't have that. So, and then it's just got a bunch of different files. We got the toolbox here. We have some sound effects, correct and incorrect, and a chime. We also have some PNG files, which we're going to be using for the stimuli. But importantly, we have the monkey.txt file. So this is where you're going to put your monkey's name. So in this case, it's Matt. And we also have the parameters.txt file. And this is where we're going to put all the different parameters for this task. So in this case, we're not having a full screen. And some of this stuff doesn't apply. But these are just some pretty common things, right? Maybe we only want to have a 1 second ITI. But we can change that as well. But what we're going to do is we're going to want to open this up. Okay, so I'm going to open the student copy so you guys can see me, but what I'm coding in real time. But this one, the other one is completed, so it should run fine if you download it. So basically what you're going to do, I go right click, show more options, edit with idle, and then right here. So I already have it pulled up right here. And we can go through line by line. One other thing that if you're using idle, if you're using another thing, it should already be there. But if you're using idle specifically, I always like to go to options, and then it should say show line numbers right up here in the top left part of the screen. That just gives you sort of a better idea of where you are in the code because it doesn't show it by default. Why? I don't know. But yeah. So let's go ahead and move through it line by line. We're going to kind of jump around. I'm going to start going through from the top, but then we're going to jump down to the bottom and then come back to the sort of the middle part where we're going to code the meat of the program. So first of all, we have here all of our import statements. And so these are just kind of like you would do in R, where you need to library all of your different packages. This is essentially what this section is doing as well. So you're importing a bunch of different packages or libraries that give you access to a bunch of different functions. So one, for example, is Pygame, which we've already talked about. So in order to even use Pygame functions, you have to import it at the beginning of your program. Another one is you need to import my toolbox. Otherwise, you won't have access to those functions either. And then another thing is we have this pygame.init, which is basically just initiates Pygame and tells Pygame, hey, we're going to start running and we're going to need you. Then next we go into setting up a couple things. So the next thing in line 29 is we're going to open the monkey.txt file and we're going to read the line of text that's in there. And so in this case, it's going to go into your folder. So it's saying go into folder, open monkey.txt, read this name, right? And then save that as the variable monkey. And so anytime you refer to the word monkey or in the variable monkey, what is stored in that variable is the text name of the monkey that is working on the program. And then it also sets the current time. It creates a variable called today. And using this function here, it sets the time and date. And so today is September 30th, 2023. So this would be 2023 09 30. Next, we set up a bunch of local variables. This is all just, once again, this is pretty boring stuff, but it's really important, I find, to set up all this stuff ahead of time because it makes calling these things a lot easier. So, like, for example, colors are a good example of that. So the color white is a variable. So if I say I'm making the variable white, I mean, I could call this anything. It doesn't have to be called white, but it is the color white. So white is equal to 255, 255, 255. And what this is an RGB code that tells the program what that color is. And so 255, 255, 255 is white. And you can Google all these codes. You can find them online. But I like to just store these as variables. So if I need to use white, I don't want to sit there and type 255, 255, 255 every time. I just want to type the word white. The program will know that that variable stores the code, the color code for 255, 255, 255. We also set up the sound. So we got a chime sound, which I like to add at the beginning of a program. So if the monkeys have fallen asleep and a new trial starts, they wake up, which does happen quite a bit. We also have to have the correct sound and the incorrect sound, and these are doing is a Pygame function, and it's looking for a .wav file that's in that folder, which we have in there, and so it's going to read them there. Lastly, one of the last things we set up is screen size and screen shape, as well as the frames per second that the program is going to operate on. In this case, we're doing screen size. It's an 800 by 600 or 600 by 800 screen. I don't know why. I think it does X first, so it's X 800, Y 600. So it's a elongated rectangle rather than a tall one. And then we set it to a rectangle at the size of this, and then we set our FPS to 60, so 60 frames per second. You can change that. That's typically what the programs run on, is 60 frames per second. But if you want to have the overall program run slower, you can drop that down, or quicker, you can increase it. But I will say, I think it might mess with some of the timing stuff. So you'd be better to do other things. Like if you want the cursor to move faster, there's a much simpler way to do that than changing your frames per second. And then this section, we're just importing a bunch of functions from my toolbox. You have to do this because apparently, I don't know why, but you can't just import the toolbox. You have to do from Matt's toolbox, import the function sound. It's just the way that it works. So you got to do it for all those functions. And if you don't need a function, you don't need the line, but I just include them all anyways. All right. So now that the program is set up, the next thing that we need to do is start making the different objects and classes that are going to be associated with the program. So the first one we need to make is an icon class. And so an icon class is this class that everything on the screen, except for the cursor, is going to be. So anything you put on the screen is an icon. You can call it whatever you want. Some people call them stimuli. Some people call them images, whatever you want to call them. I call them icons because I think that it makes the most sense in my brain. So we need to create a class called icon that has a bunch of features that any icon that I put on the screen, regardless of what it looks like, can have or abide by. A characteristic. So this is once again getting back into the object-oriented programming, right? So if I make a class called dog, I can then make lots of objects that are different dogs, right? Chihuahuas, dachshunds, pit bulls, and they can all have the same characteristics of, can they bark? Can they walk? Do they wag their tail? How fast do they run? All these sorts of characteristics are associated with them because they're all dogs. They're all part of the class dog. Now, this one is a little bit different. So we did this in my toolbox. We created a class called box, but we need to give it a little bit more. And so box is a very simple, so it's basically the box is the foundation for the icon. And so a cursor is just a box class. A cursor will end up being an object of the box class because all it is a circle that can move around the screen. But if we want things to be able to do more little complicated things, we need to create a second class, which I'm calling icon, and it's going to inherit all of the features of the box class. And so you see that here in line 105. It says class icon, so I'm creating a new class, but I'm inheriting all of the characteristics of the box class. So icon class is an example of a box class, but I'm giving it more characteristics. I know that's sort of complicated, but hopefully that makes sense. We're creating a second class that's building off of the box class. So we're going to initiate it, and then we're going to give it certain kind of arguments that need to be given to it. So for example, we need to give it a PNG file, so we need to give it an image of what the icon actually looks like. We need to give it its position, so its XY coordinates, as well as its scale, which is basically an item size, or an icon size. If you want it really big, if you wanted to cover the whole screen, it would be 800 by 600, right? But you can vary the size and everything like that. And then we just give it a bunch of characteristics. And so all these characteristics are associated, they're very similar to what's found in the box class, but it's going to allow us to change things. So for example, we can change the image's size by just changing what self.size equals and all that kind of stuff. So that's what it is. And then we're giving it one more function. This function is called mv2pos. What this stands for is just move to position. And so all you do is you can call any icon. So say we have a start button. Start button is one of our icons, and we want to move that start button to a different location on the screen. We can just say like start button dot mv2pos, and then give it in the parentheses in the argument of the function where we want it to go. And so say we wanted to go off the screen, we could give it -1,000, -1,000. It'll disappear off the screen. It'll move to a position somewhere in the void off of the computer screen. So we'll do that in a little bit. But so yeah, so that sets up the icon class. It's very similar to the box class. I'm not going to spend too much time on it, but it just has a little bit more functionality for these programs. Next, well, actually, yeah. So the next thing, and this is the last class we're going to have to make. So if the object-oriented programming is a little bit confusing, just know we're almost done with it, and we'll move on to actually making functions that the program is going to run. So the next class is a trial class. And in a trial class, we are basically creating an abstract representation of each trial that the monkey is going to complete. And so every trial, so remember, a class is just basically a category of characteristics that every trial is going to take on. So every trial needs all of its characteristics defined. For example, what's the trial number you're on? What block is this trial in? Or maybe what type of trial is this, right? So you could have like 5 different trials. They all have the same characteristics, right? They have a trial number, they have a trial within block, they have a start time, all these things, but they can vary in what happens inside that trial. And that's where we'll get into the functions, but we're not quite there yet. And so within that, you'll also, so in addition to giving characteristics, you also kind of need to start keeping track of things, because a trial is, once again, this abstract representation. So you need to keep track of like where you are within a trial. And so I do that by keeping track of what are known as phases. And so here's our first line of code to do, right, is we need to create a bunch of different phases. And right now, they just need to be set to false, except for the first phase. And these phases are what keeps track of where you are in the program. And so you could have unlimited phases. You could have a program that has 100 different phases in one single trial, right? That would probably be hard, very difficult to code, and also probably difficult for the monkeys, but you could do it. And so what we're going to do here is we're going to create a system check program, right? So how many phases do we need to have? So we need to have a start phase, right? So self.start phase, and you can call this whatever you want, but I like to call it start phase to set it apart. And this is going to be our first phase, and we're going to set that equal to true. And so phase 1, right, we have a cursor and a start button, okay? To advance to the next phase, once the cursor hits the start button, then we're going to enter, we'll just call it phase 1, right? So we go here, we go self.phase phase 1 equals false, right? Because we don't want to be in that by default. We want to be in the start phase by default. So we're setting phase 1 to false. And then that is about it for this program, right? You're only going to have 2 phases. You're going to have the start phase and then the phase where they can click the button, and then the trial is going to reset. But, you can always add more. So let's just add phase 2 equals false. Let's say phase 2 is like a blank screen delay, right? So say, or maybe phase 1 is that. So they hit the start button and then they get a long 30-second delay and then they get the trial, right? So that would be phase 2. Or maybe you want to have a third phase, right? And so say phase 1 is a blank screen, phase 2 maybe is like a distraction task, or and then phase 3 is the actual like trial where they need to decide what to pick. So that's how you set those phases. So that allows the trial class to keep track of each object trial where you are within that. In addition to keeping track of the phase, you also need to keep track of things that happen in a program. And so I call these events. So for example, Stella Meyerhoff had recently did a task with cognitive offloading in which the monkeys could touch a hint button in order to receive a hint on a delayed match to sample task. And so you want to keep track of when that hint button is clicked, right? You don't want to just have the hint button clicked and you don't even realize it because the program didn't record it. And so the way I like to do that is I just call them events. You can be more specific about them, but for now we'll just call them like event 1 equals false, right? And so we want it to set to false by default. So we're going to set it to false here. And that means that by default, the monkey hasn't done anything. The monkey has not clicked that button or whatever. So you can do this up to as many times as you want. You could have as many events in there as you would like. But we'll just keep it at 1 for now. All right. So there's a couple other things. We're still just setting up the trial class. So we're still just setting the trial class up. You don't have to add any of these, to be honest, but I do find them to be helpful. So for example, maybe we want to, maybe we're doing a match to sample and we want to have like thousands of different stimuli, right? So this is where that stimuli folder, which I'll pull up real quick, comes in handy. So this right here, right? So there's nothing in here now, but if you put 1,000 different stimuli in this folder, and then you call this function here, self.pngs equals glob.glob, and then the file path location and anything ending in .png. What this does is it makes an array within the Python program of each stimuli in that folder. And so you could have, like I said, thousands of stimuli, and you'll just have an array or a list that's thousands of stimuli long. And then this is sort of just a way to keep track. So this is just keeping track of a stimulus index, and then you can keep track of things. This makes a list of stimuli within that, and you can trace through it and all that kind of stuff. But we're not going to be doing that today. If anyone has questions about that, I can certainly show you how to do it. It's not really that hard. It's just a matter of getting all the PNGs into that file or whatever. And then the other thing you need to set up. So after that, you probably do need to do this part. You do need to set up the trial type array. And so the way these programs work is you're going to pass it basically a list of trial types, and then the program's going to move through each number in the list, and that will determine what happens in the trial. Based on how we code it, that's what's going to happen. So in this case, right, we only have one trial type. It's basically the green box is going to be appearing somewhere random on the screen, and they've got to click it. But maybe, in which we're going to do in the next one, maybe we have 2 trial types. One of which where a green box appears and one of which where a red box appears. And that's just a go, no go, right? So on the green box, they've got to click it, and on the red box, you don't click it and you just let the time run out. So that would be an example of a trial type, a task that has multiple trial types. So we do need to set this up. So let's go ahead and set this up right here under this line of code. And the way we do this is we're just going to call it self.trial type. All right, someone's calling me on the phone. Self.trial type equals, and we're going to make an array of trial types. So in this case, we only have one. So we are literally going to just fill this array with a bunch of ones. Right. And so I think based on this program, and you can change this, I think we have 20 trials per block. So we're going to want to have 20 number ones in this array. And so there's a simpler way to do this, I'm sure, just like in R, where you can be like 1 colon, whatever. But this is just how I like to do it because it allows me to change them really quickly if I need to change them into like having 2 different trial types or whatever. So 1, 2, 3, 4, 5, 6, 7, 8, 9. One more there, and then you can just copy and paste that right there and end the array. All right, so now we have an array called trial type filled with the different types of trial. And so trial type equals 1 means we're getting a green box appearing, and we have 20 of them. And so if we ever shuffle this array, it's just going to shuffle right around to ones all over the place, and it's going to give the same trial every time. But we need to set that up in the trial class so that when we make a trial object, it can refer to this array and determine what trial type is being run currently. All right. Gonna go ahead and skip this next section. This is just a way to keep track of a monkey's performance. So say you're doing a program that needs training and you want the program to automatically advance after they achieve like 80% success on 2 consecutive blocks. You can sort of use this code here, right? So you can keep track of how many trials they've gotten correct. And then you can, at the end of the block, calculate a percentage by dividing the number of correct by the total number of trials per block. And then if they get above a certain number, you can increase the self dot consecutive to 1 to 2 to 3, yada, yada, yada. That's how I sort of advance training automatically. And that way you don't have to keep track of the monkey. The program will keep track of it on its own. And then we also need to set up a object or an array called self.stimuli. This is going to be a list of where we're going to store our icon objects in a list so that we can call them at ease and put them onto the program. And then this is something you don't need to do, but I like to set up within a trial, I like to set up the icon positions so that it's a standard universal position every single time. And so I create a list called self.iconPosition. In this case, we're going to have 4 different locations on the screen. So top left, top right, bottom left, bottom right. But you could also do a dichotomous choice where you have two side by side. And so I just like to make a list of all this right here at line 183, just showing the standard XY coordinates of all the positions being used in the task. And that way, when I go to run a trial, I can just refer to self.iconPosition 1 or self.iconPosition 2. I don't need to write out and remember the exact XY coordinates. So boom, that's it. You've set up the trial class, and now it has all the characteristics of a trial you could possibly need. And so now what you can do is you can create trial objects that have all these characteristics, and you can change the values of those characteristics, but they all have them. So now that's set up. But that doesn't really do you anything because the trial actually needs to be able to do something. The program actually needs to be able to run. Right now, if I were to run this, 1, there would be errors, but 2, it would just run a white screen because we haven't created anything. We haven't created stimuli. We haven't created a cursor. We haven't even started the game yet. And so we've just been doing setup, but now we're going to actually move into the actual nitty-gritty of what makes the program work. So to do this, I know this is going to get a little bit confusing. We're going to actually skip down to the bottom. So you'll see in the code that the next part of the code. Oh, I think I forgot. All right, I'm good. The next part of the code is a bunch of different functions that the trial class has access to. And that is going to be important for running the actual program. But before we do that, we need to actually set the program up so that it runs when we run the script. And so we're going to scroll all the way down. I believe if you have the full completed version, we're going to basically jump down to line 337. All right, so line 337, it's not going to be right here, but we're going to jump down to this part right here. Or maybe it is. It's pretty close. 338. I'm 1 off. To make that easy, change that. All right, 337. So the next thing we're going to need to do is we're going to need to pull a couple things in for the program to operate. And this is where that parameters.txt file is going to come into play. So if you remember in the MATS toolbox or MHP toolbox, I forget what it's called, MATS toolbox, there is a function called getParams. And basically what that function does is it reads a text file, but it only reads every other line of that text file. Or sorry, so it reads every other line of that text file. So what we're going to do is we're going to set a variable called params equal to getParams of these variable names. And what this does is it creates a dictionary, which I've not explained what a dictionary is. It was in the Python video if you watch that full thing, but basically a dictionary is exactly what a dictionary is for people. You have a dictionary, and when you open a dictionary, there's a word, and with that word comes a definition. So in the same way, we're giving a variable, and with that variable comes some sort of definition or some value, right? So in this case, we now have a dictionary with all of these things pulled from the parameters.txt file. For example, full screen. So we'll just look at the first one. So if you open up parameters.txt, you'll see the first variable. So the function skips this line and reads this line as full screen. It's set to false, right? So the program sees that and then goes back in here and stores the value of false into this variable called full screen, right? And so it does that with every single parameter. And that way you don't have to just reference the parameters.txt file every single time. All you've got to do is call full screen. You can ask your program, if this program is full screen, if full screen equals true, then the program's full screen. If full screen equals false, then it's not. So that's a really easy way to shortcut, and that's why we do it that way. It also allows people to change things within their program. So say you realize a 1 second ITI sucks. Well, maybe you want to increase it to a 60-second ITI. You don't have to even touch the code. You can just go into that text file and change 1 to 60. So it's a good shortcut. This next thing starts the clock, which is just good for keeping track of time within the program. And finally, we create the window. So this is where we're going to say the screen equals set screen, which is a function, equal to full screen. So in this case, it's false. So when I run this program, it won't take up the whole screen. But if I were to set that in the parameters.txt file to equal true, it would take up the full screen. We then give this a caption, in which case I'm just calling it system check. This is all that does is it gives it a little text at the top of the window, kind of like you see here. See how it says system checks dash student copy.py. When you run your program, it'll be the same thing. Same with this next thing. It puts a little cute little monkey icon up there. Once again, not needed. I just like to do it because what the heck, why not? And then I set to display the display icon, and then I set the screen fill to white so that once again, this is calling that variable that we set up in the beginning. Instead of writing 255, comma 255, comma 255, I just can call the variable white. It knows what color that is. And then finally, we're going to create the cursor. And so we're finally creating something for the monkeys to use on the screen. And so the way we do this is we create a variable called cursor, in which case it's going to be an object. So our object is called cursor, and it's going to be equal to the box class. It's going to have a color of red, a speed of 8, and it's going to be a circle because circle is set to true. And so what this does is it creates a box, it creates the monkey's cursor. And now anytime I call the variable cursor, it's going to refer to that object cursor on the screen. So that's the first thing we've set up. The next thing is the data file. We'll get to that at the very end because I like to do data files at the very end because there's no point in doing it in the beginning because you don't even have your program yet. All right, so setup's complete. Now it's time to create the main game loop. This main game loop is the most important part. It's sort of the heart and soul of the task. Believe it or not, when you run a Python script, this chunk of code is actually the only part of the code that's being run by the computer. Now, that's a little bit of an oversimplification because in this game loop, we're going to call different functions from above. But when you run this, so when you double click a .py script, it's going to run through all the code above, but all that code means nothing without the following game loop. And so you should have done this in the tutorial, but we're going to also do it here too. I like keeping it at the bottom. You could leave it up higher, but I like keeping it at the bottom because you're going to constantly be jumping back and forth between functions in the game loop to make them run smoothly. And so you're going to want to, like, I just keep it in the bottom because, like, okay, I need to change something in the game loop, scroll to the bottom, and then I can change things in the game loop. So yeah, so the first thing we're going to do within this game loop, we're going to create a new object that is of the trial class. And then we're going to run the function trial.new, which we have not created yet. We'll create in a second. But that's just basically going to start the first trial and any other trial after that. So we're creating an object of the trial class called trial with a lowercase t, and then we're having that object run the function .new. Next, we're going to set a variable called running equal to true. And then we're going to make a while loop. And I think I put a link in the lesson. If you don't remember what the while loops are, you can go get a refresher, but it should have been covered in the tutorial. All the while loop is that when you give it some Boolean value, true or false, it will run while that value is true, and it will not run while that value is false. And so we're setting running equal to true, and then we're saying while running is true, run the following code. That's all the game loop is saying. Super simple, sort of. And then within the game loop, we can give it different sort of if loops or functions or things to do that will cause the program to run. And if at any point we want running to not be true, we will just have the program quit out. Okay. So while running is true, we want to run the function quit escape Q. That just allows me to close the program by hitting escape or hitting the letter Q. That was coded in Matt's toolbox. We want the timer to be set so that it's a Pygame function. It gets ticks. Just I'm not going to go too much into this, but basically it's a timer that keeps track of how long the program's been running. We want to know if the timer ever goes above the runtime that we want it to quit. Our program's not going to have that, so just ignore it, but it's in there in case you want maybe you want your program only to run for an hour or 10 minutes or whatever. You can put that in there, and all you have to do is change that in the parameters.txt file. So once again, super easy thing. You just change the start time variable. We need to fill the screen with white because that's what color the screen is going to be. And we need to draw the cursor on the screen. So the cursor will be drawn on the screen at the beginning of the task. Then we're going to create a variable, which I call select in all capitals because it's very important and you need to remember it. But basically what select is equal to is any icon or stimuli that the cursor collides with. And so this is a really good way to keep track of what the monkeys are doing within the program. So say for example, you have 12 stimuli appear on the screen. You need to know which stimuli the monkey touched with their cursor. And that variable select will tell you it. And it will tell you it throughout the entire program because while running is true, select will equal the icon that cursor is touching. So if your cursor is touching icon 1, select equals 1. If your cursor is touching icon 72, it's equal to 72. And so you can use that within the program to code the program to do certain things. And then finally, here's our loop. So if trial, which is the object we created, so if trial.startPhase, so if the start phase of trial is equal to true, then we're going to run the function trial.start. We're going to code that in a second. Don't worry. If, however, so this is an else if. So basically this is saying if this is not true and so if this is not true and trial.phase1 is true, then we're going to go trial.run trial, which once again we haven't coded. But this is the logic of the program, right? If my start phase is true, I'm not running anything. I just have a start button on the screen. If my start button is hit and I've left that phase and now phase 1 is true, I don't want the start button there anymore. I want it gone and I want the stimuli to be displayed. And so that's our two phases. And then we add this little refresh screen, which just needs to happen every single time while the program is running at the very end. So that's your main game loop. That is what the program is going to run. Now, there are some things missing here. We haven't coded all the functions yet, but when you run this in Python, the computer's going to jump to this code and it's going to be like, okay, running equals true, while running is equal to true, I can quit out by hitting Q. I can quit out by hitting escape. I've got a timer. If my timer goes above a certain time, I'll exit out. My screen's white. There's a cursor on the screen, yada, yada, yada. So now we're ready to go. We're ready to code the thing. So what we've just touched on is the basis for coding every single program in Python for the monkeys. And now we're going to get into the nitty-gritty specifics for this specific task. But everything I just taught you is applicable to every single task. And so I might make this a second video just to make sure that everything uploads. So I'll go ahead and do that in a second. But the next thing we're going to do now that we have all this foundation created is to actually go in and create the task we intend to create, which is a system check. So we got a start button, cursor hits the start button. Once the start button's hit, a green box is going to appear and the monkey is going to get rewarded for hitting that green box wherever it appears. So, all right, I will go and end this video now, and we will go ahead and do that in the next video.